Hi everyone, welcome back to Tech Initializer, your go-to channel for mastering Java, Spring Framework and beyond. In today's video, we are diving into the world of reactive programming, a paradigm that's redefining how modern applications handle data, concurrency and scalability. If you have ever wondered what powers reactive, non-blocking applications like Netflix or how to build systems that are both resilient and efficient, this series is for you. Reactive programming isn't just a buzzword, it's a game changer for developers aiming to build high performance, event driven systems. In this first video, we will introduce the key concepts of reactive programming and why it's so important in today's tech landscape. But before getting started, make sure to hit that subscribe button and turn on the notifications. Why? Because this is just the beginning. Over the next few videos, we will take you step by step through the reactive world from basics to advanced features. So you don't want to miss out, right? So let's start by understanding why reactive programming even exists. To explain this, we will begin with the concept of blocking and non-blocking code. Imagine you are at a coffee shop. You place your order and instead of moving aside to let the barista take other orders, you just stand there waiting for your coffee. This blocks others in line from ordering, making the entire system inefficient. That's exactly how traditional blocking code works in programming. Let's first look at how blocking code can be inefficient. Here is an example of traditional blocking behavior. This program waits 3 seconds before printing data fetched because thread.sleeve function blocks the main thread. Only after that, it prints processing other tasks. This blocking nature wastes valuable CPU resources. So now imagine a better scenario. You place your coffee order and step aside. The barista can now take other orders while preparing your coffee. This is the idea behind non-blocking asynchronous programming. Let's look at asynchronous version. Here the program doesn't wait, it processes other tasks while the data is being fetched in the background. This time, processing other tasks is printed immediately while the fetch data sync method works in the background. After 3 seconds, data fetched appears. The program doesn't block, so it can handle other tasks during the delay. Reactive programming takes asynchronous programming to the next level. It focuses on data streams and the propagation of changes. Think of it as an assembly line where each station processes data and passes it down the line. In reactive programming, you have two main actors, the publisher and the subscriber. The publisher pushes the data and the subscriber reacts to it. Think of it as a news channel broadcasting updates to its subscribers. In this example, the flux is the publisher and the subscribe method acts as the subscriber. Notice how simple it is to define what happens when data arrives, when there is an error, or when the stream completes. We will be discussing about flux and subscribe method in our later videos in great detail. So let's discuss the key concepts in reactive programming. One of the biggest advantages of reactive programming is its composability. You can chain operations together to transform data seamlessly. In this example, the code starts with a stream of numbers. Then it squares each number and then it applies a filter for even numbers and it finally prints the results. So it's declarative and it's very easy to read. In reactive programming, nothing happens until you subscribe to a data stream. This is called lazy evaluation. In this example, no data processed yet will be printed first, and the map operation is only triggered when the subscriber subscribes. So the next concept is back pressure. Back pressure is the ability of a subscriber to control the rate at which it receives data from the publisher. Imagine an assembly line slowing down to prevent overloading a worker. In the example, the subscriber processes data at a slower pace, which is 50 milliseconds per item. The on-back pressure drop operator ensures that excess data is dropped instead of overwhelming the subscriber. This prevents an out-of-memory error or slow performance. Finally, let's understand the difference between a hot and a cold publisher. In reactive programming, publishers can be classified as hot or cold depending on how they handle data emissions and subscriptions. Cold publishers emit the entire data stream for every new subscriber. Each subscriber receives the data stream from the beginning, even if the publisher has already started emitting data. This behavior is suitable when every subscriber needs the full data set or event stream, independent of when they subscribe. Here in the example, both subscribers receive the same sequence 1, 2, 3, 4, 5 independently. Even though the first subscriber has already consumed the data, the second subscriber starts from the beginning when it subscribes. For a real-world example, database query can act as a cold publisher because when querying data from a database, Each subscriber typically expects to get the same data set irrespective of when they connect. The other can be reading a file line by line. So when reading a file, every subscriber expects to start from the beginning of the file. So let's discuss the hot publishers. Hot publishers share their data stream among multiple subscribers. Subscribers receive data only from the point in the time they subscribe. Hot publishers are suitable for live data streams such as stock price updates or sensor readings where new subscribers don't need historical data. In this example, subscriber 1 subscribes first and starts receiving data from the beginning. After 2 seconds, subscriber 2 joins the stream. Subscriber 2 receives data starting from 5 because the hot publisher does not replay earlier emissions. Both subscribers then share the subsequent data 6, 7, 8 and so on in real time. So hot and cold publishers allow you to choose the appropriate behavior for your data streams. Use cold publishers when every subscriber needs the entire stream and hot publishers for real-time shared streams. So that's it for this video. If you enjoyed this video or find it helpful, give it a thumbs up and share it with your fellow developers. In the next video, we will take a closer look at the core features of reactive programming. You will learn how reactive streams work, the role of operators, and how to start coding with them. Trust me, you don't want to miss this one. Thanks for watching.